We're starting Unit 2, which is about bivariate data, which means that we are looking at two variables at the same time. So Chapter 7 starts out with scatterplots, association, and correlation. Starting with scatterplots, scatterplots show the relationship between two quantitative variables. How can you tell if a variable is quantitative? If you said it has units, you would be correct. But we use scatterplots to see patterns and relationships and trends between the two variables, as well as the occasional outlier. They are one of the most common and effective displays for data and are the best way to start observing a relationship between two quantitative variables and then deciding where to go from there. Looking at scatterplots. So when we were dealing with histograms, we described the distribution, the shape, center, spread, and of course it had to be in context. With scatterplots, we describe what is called the association, because we're looking to see how two variables are associated with one another. So in this case, we describe the direction, the form, the strength, any unusual features, and of course it needs to be in context. So when we are describing association, the direction is talking about where the data run. So negative means that it's running down, positive would mean that it's running up. Those are your two possibilities. For form, we're looking to see if there's a straight line relationship. That's really what we're hoping to find. So linear is a straight line. Curved, there's a couple of different scenarios for curved data. If it's just a gentle curve while increasing or decreasing steadily, we can often make that data straight, which we will do when we get to Chapter 10. If the data has a sharp curve, then we really can't use the methods that we're going to learn in this class, and it takes more advanced statistics to be able to analyze that data. The other option with form, if it's not linear and it's not curved, is that there's no pattern at all, and sometimes that happens. When we're talking about strength, we're talking about how strong the relationship is. So if it's a tight cluster, all the data values are tightly together, then we have a strong association. If it's more of a slight cluster, we're looking at more of a moderate strength. And then if they're hardly clustered at all, there's a weak strength. We will learn about a numerical value to be able to determine strong, moderate, and weak, but that will occur a little bit later on. Then we also want to look at unusual features. So unusual features is something out of the norm. So outliers, again, they're standing away from the overall pattern. For example, I want to describe the association between central pressure and wind speed. So here's the scatter plot for it, and we can really describe the association in one sentence. You just have to make sure that you are including context, direction, form, strength, and any unusual feature. So I would describe it as this. The association between central pressure and maximum wind speed appears to be a negative, strong, linear relationship. In that one sentence, I gave the context because I specified what the variables were. I explained that it was linear because the pattern is following a straight line. It's negative because it is going down. And I said it's strong because the values appear to be tightly clustered. If you said moderate in this case, I would probably accept that. Again, we're going to learn a numerical value to really determine that. So right now, it is a little give and take. Roles for the variables. So understanding which variable goes on the x and y axis is important. You guys have heard of independent and dependent, and we're really kind of going to stick to that, but we have a little bit different vocab. So we want to know the relationship between the two variables and what role each variable plays. So we have the explanatory or the predictor variable. This is typically the x, which is also your independent variable. But we're really going to call it the explanatory variable because x will explain what y is, or we use x to predict our y value. The y value is then called the response variable, which is the dependent variable. We call it the response variable because we get y in response to what x was. So trying another example, I want to describe what you might expect the association of the scatter plot to look like for each situation, and identify the explanatory and response variable. So I suggest that after I give you each situation, that you pause and try and see what you come up with on your own, and then of course I'm going to give you guys the answer regardless. I'm going to start by explaining the explanatory and response variable, and then describe what I think the association would look like. So our first situation is calories consumed and weight loss. So in this case, I'm going to say that calories consumed is going to be our explanatory variable because the number of calories is going to explain the weight loss, which means our weight loss is the response variable because we get that in response to the number of calories. So the association between these two variables is going to be a linear relationship, have a negative direction, and probably be moderate to moderately strong. There's going to be some other variables involved that might account for the weight loss, but overall, the more calories, the less weight loss, or the less calories, the more weight loss. So we're going to be decreasing, but it'll still have a straight line relationship. Our next scenario is drug dosage and degree of pain relief. So in this case, I would say that the degree of pain relief is going to be our response variable, and our drug dosage is our explanatory variable, because the amount of drugs you take is going to explain how much pain you have left. In this case, I would say that it would have a positive direction and would probably be pretty strong. However, I'm going to say that this is going to have a slight curved pattern because eventually your pain will be relieved, and if you increase the drug dosage, it's not going to help relieve the pain. But it would probably be fairly linear until a certain point, and then after that it would level off. The next scenario is hours of sleep and scores on a test. I would say that this one might have some form of a linear relationship. If it does, it would be extremely weak. Overall, it's not going to be a great relationship. Oh, and I forgot to do the explanatory and response. Explanatory would be your hours of sleep. Response would be the score on the test in this situation. Sorry. But again, I would say that this is going to be a very weak or no association. The last scenario that we're going to look at is shoe size and GPA. In this case, there's going to be absolutely no association. I would say shoe size would be your explanatory variable and GPA would be your response, but this is going to be scattered all over the place. Shoe size has no effect on what your GPA is. Sorry, so people with big feet, you don't have a higher GPA. Units. So units are important because it's how we know that we're dealing with a quantitative data, but the scatter plot shows the relationship between two variables. That relationship doesn't change regardless of the units. So, for example, here we have a scatter plot showing the association between height in inches and weight in pounds. If I were to describe the association, I would say that it is moderate, positive, and appears to be linear. And we may have an outlier at 72 inches and 280 pounds. If I look at this scatter plot, note that the scatter plot is exactly the same, but I've changed my height from inches to centimeters and my weight from pounds to kilograms. Nothing actually changed here though, except the scale on your X and Y axis. This is because the relationship didn't change. Still, as you get taller, you tend to weigh more. There's going to be some reasons why that's not always true, so it's not as strong of a relationship, and of course there's going to be the occasional outlier. But overall, the units don't matter when we're talking about the relationship because the relationship doesn't change. Alright, last thing is correlation. We're going to talk a lot more about correlation in Unit 2, but we're just kind of going to have an introduction to it right here. So correlation measures the direction and strength of the linear association between the two quantitative variables. Note that linear is underlined. It's because it only measures the direction and strength for linear association. If the data is not linear, you cannot use the correlation. So we want a nice way to determine how strong an association is. Say a number between -1 and 1 would be really nice. Well, we have that. Correlation is going to be that number. Correlation is not the relationship between two variables. Again, we will emphasize this a lot. The association is the relationship between two variables. And that's it. Again, we're going to talk more about the correlation as we move on in Chapter 7, a lot in Chapter 8, and then again in Chapters 9 and 10. But correlation is not the relationship. The association describes your relationship. All right, that is it for tonight.